Hello, welcome to next session. In this session, we'll solve some questions of machine design. The topic is riveted joint. Question number 1 to 4 carries a common statement. The statement is a double riveted lap joint is made between 15 thick plates. The dimension of rivet hole and rivet diameter are 26 and 25 respectively. The pitch of the rivet is 75 If the ultimate stresses are 400 MPa in tension and 320 MPa in shear and 640 MPa in crushing for both rivets and plates. Question number 1. The maximum tensile load per pitch without rupture will be option A 294 000 Newton, option B 300 000 Newton, option C 250 000 Newton, option D 314 200 Newton. Question number 2. The maximum shearing resistance of rivets per pitch. Option A 314 200 Newton, option B 162 100 Newton, option C 200 000 Newton, option D 294 000 Newton. Question number 3. The maximum crushing resistance for joint per pitch. Option A 314 200 Newton, option B 480 000 Newton, option C 240 000 Newton, and option D 200 Newton. Question number 4. Efficiency of joint is option A 66.67%, option B 33.33%, and option option C 32.15%, and option D 65.33%. So here the tearing strength of the riveted joint is given as. So this is for when the load is applied in double riveted joint, the joint will fail. Tearing of plate will take place, and tearing of plate will take place either from this part or from this part. Both part, if one of the part is gets rupture, then it will be assumed as failure. Okay. So the failure when load is applied will be like that. So this part will rupture, or in this case either of this part or this part double riveted joint can rupture. So if one of the part fails, then it is failure. So here this is your PP is your pitch, and this diameter it is D, and this is your P minus D. Okay, and this is P minus D, and this length is now P minus D, and the area for tensile load is P minus D into P. That is area for failure of plate, P minus D into T. Okay. So P minus D into T. So here the D is diameter of hole. Okay. Diameter of hole, because we are considering the failure of plate. So we will subtract the diameter of hole, or R from this and R from this. Okay. We will subtract the hollow portion of the plate. Okay. So tearing of so the area is P minus DH. DH is diameter of hole, and into T. And if we are considering tearing of plate, then we will take tearing strength PT and should be equal to load applied. Okay, that is the area and that is stress. So diameter of hole is given as 26 Diameter of hole is given as 26 So we will take 26. T is 15 pitch is 75 and sigma T is 400 MPa. Tearing strength is given as 400 MPa, or tension is given as 400 MPa. Pitch is given as 75 and thickness is given as 15 Okay. So the load comes out as 294 000 Newton. So answer to question number 1 is A 294 000 Newton. Next is maximum shearing resistance of rivet per pitch. So the shearing strength of the riveted joint in a lap joint is given by. So this is now this is your double riveted joint. If both of the rivets fail from this and from this portion, then the failure will occur. Okay. So we'll take the area of this rivet for shearing and area of this rivet. So the total area is n into 2 into pi by 4 d square, because this is the shearing area, like this. When load is applied, the rivet will shear for like this. As there are two rivets, so if both will fail, then the failure in shearing will assume to occur. Okay. If both will fail, then the failure will assume to occur. Okay. So the area for shearing is n into pi by 4 d square, and will take shearing strength, and that will be equal to load. So n is the number of rivets per pitch. Now as it is double riveted joint, n is 2. Diameter is 25 mm, and sigma shearing strength is given as 320. So the load is here 314,200 Newton. So answer is 314,200 Newton. Option A. Next, maximum crushing resistance of the rivet per pitch. So crushing resistance of the rivet per pitch is given by crushing area, as there are now when the load is being applied here, so this rivet can be crushed by this plate, by this load, by the plate. Okay. And similarly this rivet can also crush. Okay. So crushing of both the rivets can take place. So crushing of rivets like this. Okay. Now there are two rivets, double riveted joint, so we take two. Now here we have taken the diameter of rivet, because shearing of rivet is taking place, and here we will also take the diameter of rivet, and area for the shearing for crushing is here d into t, because the rivet will crush against the plate. So n is your 2, d into t is your crushing area for one rivet, and sigma is crushing strength. So the load comes out as 480 Newton. So answer is option B. Now next and fourth question is efficiency. So efficiency of joint, the strength of the joint can be considered as the minimum of these three. The minimum load which it can sustain. So the strength of the joint is minimum of PT, PS or PC. Okay. And minimum is 294,000. 294,000 for tearing or tension. And if there is no riveted joint, then we have a plate of length P and thickness T. So then its strength will be P into T into sigma T. So this will be your strength of the plate. As riveted joint is decreasing the strength of the plate, so there will be efficiency, and efficiency is minimum of these load bearing ability divided by strength of plate, and strength of plate is 450,000, and that minimum of PT, PC, PS and PC is here 294,000. So answer is 65.80%. So here one thing has to be noted, that the tearing of the plate takes place where tearing of the plate takes place, but it means the tension tearing of plate takes place, whereas crushing and shearing of rivet takes place. Here it is rivet, here it is plate, so diameter of the hole is taken while calculating tearing load, and diameter of the rivet is taken while calculating shearing and crushing load. Okay. So answer to question number 4 is D.